Concept 3, addition and subtraction with scientific notation. So, addition and subtraction with scientific notation is a little bit different from the multiplication or division. With multiplication and division, the easy part of the problem were the exponents. Right? That was the easy part because we have those special rules when we have the same base. With addition and subtraction, we don't. So this actually gets more tricky with addition and subtraction. Okay? We can't just do our subtraction with our coefficients without changing or at least looking at our exponents. Okay? I've actually pulled these numbers. This top number, 2.98 times 10 to the 5th, this is the population of Anchorage. Okay? Anchorage. This 5.6 times 10 to the 3rd is Homer. So if our question is what's the difference, or how much larger, how many more people live in Anchorage than Homer, this is how we could set up our problem. Alright, but if we just subtract these numbers, if we just look at these numbers by themselves, it almost looks like Homer's bigger than Anchorage. And we know that's not true. So, in order to do our math here, do our subtraction, we're going to need to make these exponents the same. Okay, we have to get them so that they're equal. So what we're going to do is we're going to move the decimal point, and I almost always advise you move the decimal point of the smaller number, so the one with the smaller exponent, because it'll save you some time later on. So we're going to move this number so that these exponents match. Okay, so we're going to leave 2.98 as it is, 2.98 times 10 to the 5th. And in order to get this up to, right, we're going to have to add 2 to get that to equal 10 to the 5th as well. We're going to have to move this over 2 to the left. Right? We're making this number larger, so we've got to make this number smaller. So 1, 2, and we get 0.056. 0.056. Okay, and now we can do our subtraction. Alright, these we don't even have to worry about. Okay, those are going to drop down. Those are going to be the same. We're going to have 1 10 to the 5th here. And then we can do our subtraction. Okay, we've got a 0 there. We're going to have to make this a 7, 10. So we've got 6 minus 10 is 4. 5 minus 7 is 2. Then we have a 9. So 2.924 times 10 to the 5th. And that is how much larger Anchorage is than Homer. And we can see because we increased the smaller number, right, we brought this up to 10 to the 5th, we still have this in scientific notation. Okay? If we had moved this decimal place over for our larger number, and we brought this down to 10 to the 3rd, and we had 298 minus 5.6, we would still get the same number, but we'd end up having 292.4 times 10 to the 3rd, and then we'd just have to convert this back into proper scientific notation. That's why I advise you change the smaller number. Okay? Let's look at another one. So here we have an addition. Okay? Again, just like with division, I recommend your first step be writing it vertically. So 3.2 times 10 to the negative 3rd plus 3.2 times 10 to the negative 2nd. Okay? Now, a lot of times when students see something like this, they will get a little confused, and they'll just say, okay, well, that's going to be 0, and I don't have to worry about that. Okay, but let's convert these to standard notation. All right, let's make these their actual equivalents. So 3.2 times 10 to the negative third. We're going to move this to the left 3 times. 1, 2, 3. So we have 0.0032. And this one, negative second, so we're going to move it 2 times. And that's going to be plus 0.032. Okay? And you can see that the place values make a big difference when we turn it into a standard notation. Okay? We have 2, 5, 3, 0. Okay? And then we could turn that back into scientific notation. Move this back 2. We have 3.52 times 10 to the negative second. Okay? You can always, well, you can't always, because sometimes your numbers are too big or too small to do this, but as long as your numbers are reasonable, you can turn it into standard notation, do the addition or subtraction, and then convert it back. Okay? If we were going to do this without converting it, 3.2 times 10 to the negative third, 3.2 times 10 to the negative second. Okay? So we are just going to leave it in scientific notation, but we're going to convert one of these to be the same as the other one. So we're going to have our exponents be the same. We still want to convert the smaller one into the larger one. Okay? Which one of these is smaller? Well, negative 3. Negative 3 is of a lower value than negative 2. So we're going to want to make this number larger. Move this decimal place over, and we have 0.32 times 10 to the negative 2 now. 3.2 plus 0.32 is 3.52 times 10. We bring down our exponents, negative 2.